Question 9.2. Sketch the graph of f, clearly indicating the intercepts with the axes and the turning points. Alright, so this might be a bit overwhelming at first, but we are being asked to draw this cubic graph. And it is a cubic graph because we can see here, and we have, if we didn't have it in this form, we could see that we have a quadratic here and a linear, so we are dealing with a cubic graph when times out, multiplied out. So first things first, we need the turning points of our cubic graph, but fortunately we've already calculated this, so that's great. So we already have these, so let's write them down. Turning points. We have minus a third, 500 over 27, and we have 3 and 0. What else do we need though? Well, we need the x-intercepts. So, what are those? We don't know those yet, so let's determine them, calculate them. We know when we have a function and we want to find the x-intercepts, our y value will be equal to 0. So simple, all we need to do is plug in our y value, which is 0, into our original function and solve for x. So let's do that. Y at position 0, yx, y will be 0, and we solve for x. So we will have x plus 2, x squared, minus 6x, plus 9. And we see they've already factorized the 1x value for us, so we don't need to continue any further there. That's fantastic. Now we need to just factorize this quadratic here. So let's do that. X plus 2, x. All right. Remember I was talking about that rule with the signs when factorizing quadratics. If the constant sign is a plus, we can immediately say that the sign in for the singular x exponent, x minus 6x, that term over there will be the sign that is throughout in our factorized form. So to reiterate, if the constant sign is a plus, whatever our linear, because x is the power of 1, whatever our linear term's sign is, that will be the sign throughout in our factorized form. And after that, all we need to do now is determine what these numbers are. So the factors of 9 are 9 and 1, 1 and 9, 3 and 3. So what combination of these pairs over here will give us our original quadratic? Well, let's have a look. We want minus 6. So 3 and 3 looks pretty good. What happens if we put a 3 here? We'll have x squared minus 3x plus 9. Yep, that gives us x squared minus 6x plus 9. Perfect, so we have factorized our original function. Therefore, values for x where this function will be equal to 0 will be x equal to minus 2, x equal to 3, and this is the same answer throughout. So at the points x equal to minus 2 and x equal to 3, y will be 0. So we can rewrite this as minus 2, 0, 3, 0. Great stuff. Now we have all the information to start creating a skeleton for our graph. So let's do that. Let's make that a bit longer. There we go. Awesome. All right, so let's write down all our points. So we have -2 and 0, so let's put him over there. That's an x-intercept. And we have 3. And I'm going to label my intercepts, because I like to do that. Do they ask us to do that? Yes, indicating clearly the intercepts, so let's label our intercepts. Now, where are our turning points? Our turning points are located at 3 and 0. That's an easy one. So 3, let's do over here. 3 and 0. And minus a third, 527. What's that? 527. Wait, was that the correct? Oh, that's just really, really high. $527, 18.52. Yo, that is just really high. That's a bit strange because our y-intercept is quite dramatically small. So our graph's going to look a bit wonky, purely because the difference between the turning point over here is going to be so much more than the difference of our y value. So it is correct, but it might not look so great. That's just because our values are so different. Okay, but 500 over 27 is about 18.52. Okay, so now let's write that a third. Let's just put him somewhere over here. That'll be there. So that's minus a third, 18.52. So that's our one turning point we determined earlier. And the next turning point was 3 and 0. And that's a nice, easy one. We already have that here. Oh, do you notice something? Our turning point and our x-intercept are the exact same. Right there. Exact same. So we must notice that that's important. So when drawing our graph, our turning point actually lies on the x-axis. That's interesting. Okay, so let's start drawing our graph. If it's not obvious, because remember, cubic is going to look like this. 1, 2, or 1, 2, or, I don't know, 1, 2, like that. If it's not obvious how our graph is going to look, I'm going to show you a trick to determine how to draw it. Well, not a trick, but some more theory, very useful theory. If we find the second derivative, which will be equal to 6x minus 8, and we plug in any x value we want, so let's plug in 1. This would be 1 over here, minus 1. We will get 6 minus 1 minus 8. Minus 6 minus 8. 14 minus 14. My arithmetic is terrible. Yes, it is. Minus 14. Whatever value we get when plugging in an x value, if it's a negative, our graph is increasing. If we'd gotten a positive, our graph is decreasing. And it makes sense here because I plugged in minus 1, which is this point over here. Let's say, for example, by looking at our graph, we know our graph is going to do that. It's going to cut the x-axis and turn at that turning point. Cut that y-axis and continue. And I'll draw it now properly, but we know our graph's going to do that. Well, we see that our function's increasing here. So our derivative is positive. And would you look at that? When we have a minus at minus 1, when we plug in minus 1 into our second derivative, we get a minus 14. And we know if the sign is minus, our graph is increasing at that point. So if you're ever unsure about how your graph looks next to points, like the x-intercept or the turning points, just take an x value in between those points, plug it into the second derivative. If it's a minus, your graph is increasing at that point. If it's a positive, your graph is decreasing at that point. So just some useful theory to know there. All right. But now this is quite easy to draw. We have a turning point, y-intercept, turning point, x-intercept. So our graph's going to go up, turn, cut. That was terrible. Turn, that was terrible. Turn, cut, turn. And this must try be on the x-axis there. And that's what we're finished. That's perfect. It's not a nice looking graph. It looks something like this. But that is correct. So we've got our turning points, x-axis, and let's just, to be safe, say y equals 0 here for the x-intercept of the y-axis. And that's all we had to do. We are finished.